In 2050, long after midnight in the world's major financial capitals, a different kind of heartbeat keeps the global elite on time. Deep beneath a discreet glass tower, a single failure in a hidden assembly hall could silently shift departure boards, delay negotiations, and freeze auction rooms where millions move with each raise of a wrist. The paradox sits at the center of this world, the most coveted symbols of human craft. And status now depend on a sanctuary where not a single human hand is allowed to touch the product until the moment it is complete. The complex rises above an old European riverfront district, its facade calm and understated, hiding a labyrinth engineered around silence and vibration control. Inside, the ground floors host galleries and salons where collectors admire finished tourbillons under carefully tuned light. Several levels below, isolated by magnetic damping and air-gapped corridors, the true heart of the brand hums in a controlled near vacuum, its temperature fixed to 1/10 of a degree and dust reduced to a statistical rumor. Material arrival begins long before dawn. Autonomous cargo pods, matte black and unbranded, slide into shielded loading bays beneath the complex. They carry sealed cassettes of pre-refined metals, platinum ceramic alloys for cases, amorphous carbon steels for main plates, graphene-reinforced springs, synthetic sapphire blanks grown in off-site crystal farms. Each cassette passes through an airlock where atmospheric conditions match the core of the facility. Intelligent racks receive them and glide along ceiling rails, moving with such precision that no vibration propagates beyond a fraction of a micron. Handling is no longer a matter of forklifts and pallets, but of choreography executed in 3 dimensions. Swarms of slender logistics robots climb vertical storage towers, their articulated limbs tipped with soft ceramic pads that never scratch or compress. They identify each cassette by quantum lock tags, verify provenance, alloy composition, and microstructural fingerprints. A cassette destined for balanced spring production diverts along one corridor. Another, containing sapphire for crystal lenses, arcs away along a separate track. Everything flows as if the entire inventory were a single continuous organism. Pre-processing cells sit along a circular ring, each dedicated to transforming raw stock into watch-ready blanks. Platinum ceramic rods enter induction ovens where electromagnetic fields realign micrograins for optimal fatigue resistance. The material emerges into extrusion lines that form ultra-precise case profiles, which then cool on levitating conveyors that prevent any surface contact. Nearby, plates of amorphous steel are laser scanned, then sliced into main plate blanks by femtosecond cutters, each cut planned to avoid microscopic inclusions that decades later could become failure points. Deeper in the ring, machining and processing take over. Here the hallways open into a cathedral-like volume dominated by clusters of nano-CNC units arranged like islands in a still sea. These machines carve gear teeth only visible under extreme magnification, drill jewel holes whose tolerances are measured in tens of nanometers, and skeletonized bridges along flowing organic lines that balance aesthetics and structural integrity. Coolant is a precisely engineered gas mixture, passed through cryogenic filters and ionized to trap stray particulates before they ever touch a component. In a neighboring sector, photonic lithography pods project intricate patterns onto ultra-thin ceramic films that will become circuit boards for hybrid mechanical quantum timing modules. Entire modules emerge from the pods fully patterned, ready to be etched and released into the handling stream by wafer-thin robotic paddles. Once machining is complete, components enter a zone where cleaning borders on ritual. Microparts travel through cascades of plasma baths, supercritical CO washers, and ultrasonic fields tuned to avoid harmonics that could induce microcracks. Each gear, jewel, and bridge hangs in levitated suspension while multispectral scanners search for residues invisible to normal inspection. A single contaminant particle triggers an automatic loopback, sending the part through another purification cycle rather than risking long-term drift in timekeeping. Inspection is where the facility's obsession with perfection becomes visible. Arrays of autonomous microscopes line a darkened gallery, each one poised over a rotating carousel of parts. Artificial intelligence systems trained on decades of failure analysis examine edge sharpness, surface grain, and optical reflectivity, comparing them against digital twins of every component. Imperfections too small for human eyes become disqualifying events. The rejected parts are dissolved back into elemental feedstock, tracked, and reincorporated into future batches with adjusted process parameters. Assembly occurs not on a single line but within nested clean domes anchored along the central axis of the facility. Inside each dome, modular robotic arms resemble skeletal hands suspended in zero gravity. They pick up balance springs by their outer coils, lower them into polished, ultralight cages, and secure them with forces so gentle they barely register on conventional sensors. Other arms fit microgears into place, align jewels, and tension springs in sequences that would demand superhuman steadiness from a living watchmaker. Each movement is guided by a real-time digital replica of the watch, making micro-adjustments to compensate for minute variations in material properties. Customization has evolved into a parallel orchestration rather than a manual afterthought. Once a movement passes internal tests, it travels through a ring of personalization cells. Here, laser engraving systems apply patterns inspired by individual star maps, biometric rhythms, or commissioned artworks. Nanometer-scale deposition units lay thin layers of color-shifting ceramic along bezel edges, while micro-robots inlay lab-grown gemstones arranged according to generative design algorithms that balance symmetry and uniqueness. Packaging and configuration embrace the same meticulous logic. Completed watches enter an atmospheric vault where straps and bracelets, themselves made from programmable materials, await pairing. Smart cradles clasp each watch, upload its configuration to encrypted cloud clusters, and run final synchronization routines to align mechanical oscillation with satellite-calibrated time references. Cases are grown from recyclable composite shells on demand, their inner surfaces lined with impact-damping aerogels and embedded chips that track provenance, servicing history and ownership without exposing sensitive data. Dispatch turns the invisible heart of the complex back toward the visible world. Robotic conveyors move sealed presentation cases into discrete outbound pods. Routing decisions and delivery paths are optimized by systems that weigh risk, weather patterns, and the timing of high-profile events where a new piece might first appear. When a case finally opens under the lights of a private showroom or aboard a quiet jet cabin, the watch resting inside still carries no memory of human touch. Yet on its dial, every polished edge, every perfectly balanced hand, and every measured tick speaks of an entire hidden ecosystem designed so that the world outside never sees the moment when its sense of time almost faltered.